All right, let's dive into one of the most mind-bending ideas at the very edge of physics. It's a concept that really messes with our fundamental gut feeling about how reality works, specifically the arrow of time. And look, this isn't science fiction. It's a serious question that physicists are grappling with in the quantum world.
So let me just throw this out there right at the start. It's a question that sounds completely impossible, right? What if a decision you're going to make in the future could actually reach back and have an effect on something that's already happened? It sounds like a total paradox, but believe it or not, some seriously baffling experimental results are forcing scientists to at least, consider it.
And to really see why anyone is even entertaining this idea, we've got to look at a real-world experiment that seems to be spitting out data from the future.
Yeah, it's a mouthful. It's called the Causally Ambiguous Data Selection Experiment, or just CADS for short. And what it found is, well, there's no other word for it. It's strange.
Okay, the order of events here is absolutely crucial, so follow me on this. First, a detector starts counting photons for a set amount of time. We'll call this the predecision period. Now, after those photons have already been counted, recorded, done, a computer randomly decides how much longer the experiment is going to run. And here's the bizarre part. The number of photons they counted back in that past period seems to correlate with the random choice the computer made in the future. It's like the experiment somehow knew how long it was going to be before that was even decided.
So an experiment like CADS is just so weird, so against our intuition, that it basically demands an explanation. And one of the most radical ideas being kicked around is this concept called retrocausality.
So what is it? Put simply, retrocausality is just the idea that cause and effect doesn't always have to be a one-way street. It suggests that maybe, under very specific quantum conditions, an effect can actually come before its cause.
This really does flip our entire worldview on its head. I mean, we live in a world of forward causality. You drop a glass, then it shatters. The past causes the present. Simple. Retrocausality says that maybe, just maybe, the arrow of time could be more like a two-way street. Now, this isn't about hopping in a DeLorean to change history. It's more subtle. It suggests that what's happening right now isn't just determined by the past, but it's also being shaped by conditions that have to be met in the future.
Now, you might be thinking, why would anyone invent such a wild idea? It turns out it's not just to explain these weird experiments like CADS. It's also a potential solution to one of the oldest, deepest puzzles in all of physics. And that puzzle was famously described by Albert Einstein himself. He called it spooky action at a distance. What he was talking about was quantum entanglement, this bizarre phenomenon where two particles can be linked, and I mean really linked, so that measuring one seems to instantly affect the other, no matter how far apart they are. Miles, light years, it doesn't matter.
And this isn't just some philosophical head-scratcher. A physicist named John Bell proved, mathematically, that any theory that wants to describe quantum mechanics correctly has to include this non-locality. That means the connection between these entangled particles has to be instantaneous, faster than light. And that just seems to break the universe's ultimate speed limit, the one set by Einstein's theory of relativity.
So here's where retrocausality offers a way out. It says, hold on, maybe there aren't any faster-than-light signals. Instead, the influence takes a kind of zigzag path through space-time. A signal travels forward in time to the first particle, like normal, while another signal travels backward in time from the second measurement all the way back to the moment the particles were first created. Everything still obeys the speed of light, it just doesn't all happen in a straight line forward through time.
Okay, I know, a zigzag through time is a cool idea, but how would that even work? Well, one of the most famous retrocausal models gives us a great picture to hang on to, a handshake across time. This comes from the transactional interpretation, which was developed by a physicist named John Cramer. He imagined a quantum event, like a particle traveling from A to B, not as a simple journey, but more like a negotiation, a transaction that happens across time.
And the way this handshake works is just beautiful. Imagine a source sends out a wave forward in time, that's the offer wave. Potential absorbers out there in the universe, they get this offer. And then they send a confirmation wave backward in time. When these two waves meet, they complete the handshake across space-time. That handshake, that finished deal, is what we see as a particle actually traveling from the emitter to the absorber. The whole event is settled all at once, constrained by both its beginning and its end.
And Cramer's model isn't the only game in town. There's another one called the two-state vector formalism.
It also suggests that to really describe a quantum system, you can't just know its state in the past, you also need to know its final state in the future. Reality, in this view, is defined by both of its boundaries in time.
Of course, the second you start talking about the future influencing the past, all the alarm bells start ringing, right? What about paradoxes? Could you change the past?
This is the big one, the classic objection. It's often called the bilking paradox, but it's basically the same logic as the grandfather paradox. If a future event is supposed to cause a past one, what stops you from seeing the past event happen and then just deciding not to do the future thing? You'd have an effect with no cause. Now, people who support retrocausality argue that the universe is self-consistent. The very conditions that would let you bilk the cause would also somehow prevent the effect from ever happening in the first place.
And this brings us to this amazing philosophical puzzle called Newcomb's paradox that really gets to the heart of the problem. So imagine that there's this super predictor who knows your future choices with perfect accuracy, 100% of the time. They show you two boxes. Box A is clear, you can see $1,000 inside. Box B is closed. Now the predictor says, I put $1 million in box B yesterday, but only if I predicted that you would choose to take only box B. If I predicted you'd take both, I left box B empty. So what do you do?
And this is the paradox. On the one hand, the logic is simple. The money is either in box B or it's not. The predictor made their move yesterday. The past is fixed. My choice now can't change what's in the box, so I should take both to get either 1,000 or 1,000,000 and 1,000. But the other argument is just as strong. The predictor is never wrong. Everyone who took only box B walked away a millionaire. Everyone who took both got just the $1,000. It's like the predictor's past action is somehow causally tied to your future choice. This puzzle perfectly lays out the battle between our normal view of causality and the weird logic of retrocausality.
So where does all this leave us? Is time just a one-way street, the way it feels? Or is there something much deeper going on that our everyday experience just doesn't prepare us for?
Look, let's be super clear here. Retrocausality is not a proven, accepted fact. Not by a long shot. It's still deeply controversial, but it is a serious idea that's an active area of research. The most important thing to take away is that it's a tool for thought. It's an idea that forces us to stare down the biggest questions in physics, the nature of time, of cause and effect, of reality itself. By exploring these wild ideas, we're really testing the absolute limits of what we think we know.
And that leaves us with a final, pretty staggering thought to ponder. What if the story of our universe isn't just unfolding from the Big Bang forward? What if, in some deep, subtle quantum way, it's being written from both ends at once, with the past and the future collaborating to create the present moment? It's an absolutely mind-boggling idea, and definitely one worth thinking about.